Welkom bij een nieuwe aflevering van de Data Discovery Channel. Vandaag heb ik twee gasten in de studio, twee collega's van mij. And for that reason we switched to English, because one of them is Lucía. Welcome, Lucía. And the other one is Willem. Willem speaks Dutch, but
I can do English as well, so
that's why we do it in English today. And today we are going to talk about a topic related to machine learning, MLOps. And I think a lot of people will think with MLOps, sounds like ops, DevOps for machine learning, but that's probably not covering it at all, right?
not entirely, no. No, but they're in the right direction. I mean, it's about operating machine learning models, and that's the main focus of it. But it covers the whole thing from start and with an experiment, trying things out, up until running into production and gathering feedback for the next iteration.
Yeah, so we're talking about iterative things like with DevOps. We're talking about versioning, probably pipelines to deploy everything, that kind of stuff.
Yeah, I don't know if everybody's aware of what DevOps actually is. It's so nowadays we like to work agile, iterative processes. We've discovered that building one piece of software in one go is not going to happen. People will change requirements. We will learn how to use it in production. The same thing goes for machine learning. So the idea is we want to make sure that every time we release a new version of a model, it's better than the old one. That's one reason why you want MLOps as a way of working, actually. The other reason is you want to build as high quality possible as you can. So that means in development, we're used to running automated tests. The same thing should happen for machine learning code as well, of course.
Yeah.
So there's a large overlap between DevOps on the one side, automated testing pipelines, and machine learning on the other side.
Yeah, basically it has the same goals.
Yeah, and I would say like a good summary of what it is DevOps plus something else. So the DevOps concept will stay the same. It's not like we change them, but I would say like one of the main differences between a regular software project and a machine learning project is that we have code as well, but we also have a model and we have data. So we need to apply the same DevOps concepts on the code, but also on the model and on the data. Like they are part of the application. So that's the main thing.
Good summary.
Yeah.
Yeah, it feels that way. Also in the daily workflow that we use.
Yeah, exactly.
We're using the same tools actually as a normal dev engineer, except we build software that's actually compiled into something that then produces a model which is used in the software again. That's the extra stuff that we do.
In my impression, I might be wrong, but I think there's a lot of companies working with machine learning. They're experimenting. Maybe there's some companies doing things in production already. Of course, there will be companies doing that. But is my impression right that a lot of companies start to experiment and put something experimental into production?
Well, in the end, a machine learning project is experimental in nature. So we might have a first hypothesis on the model that we want to build. And we might train the model with the data that we already have, and maybe the performance looks good enough to put it into production based on the performance metrics that we chose, etc. But then once it's in production, it's always gonna degrade in some way. Maybe because we'll get more production data than we have at first, of course. So the more data we have, the more we could improve it. But also because maybe the data can change.
The whole world is changing.
Yeah, exactly. Yeah. So it's something that we will always have to iterate on. And maybe something that works in an experimental phase doesn't work in production, or maybe it works the first months, but then it stops working at some point.
But without a good MLOps process in place,
it can be quite challenging to stay in production. So
basically.
One of the many things that we see companies do these days is they build a model on an experimental environment, usually their own laptop or some server inside the company, and then they zip it up and put it in production. That's basically their workflow. That works
having
fine.
No idea which version is in production.
Absolutely not. Well, the first time you know which version it is. That's the one version you have. Yeah. But then what happens is, as the world changes and you learn how to improve, then it becomes a challenge. What version do you want to use next? And is that, that's the extra challenge in machine learning, is the second version actually better than the first one? You've done all the things right, so most data scientists will first grab a data set and then they split it in two parts. They have a test set that they use to validate, is my model actually recognizing the data that I gave it, and a training set that they use to train it. What happens is this validation set is chosen once, but the world changes, so you don't know if that's correct. All you can do is run it again and hope for the best. Yeah, that's the thing. So you constantly have to keep up and make sure that you do the right thing during the initial phase of training, but then you have to run it in production because you don't know how the world looks at that point.
Yeah.
So yeah, it's without MLOps, it's pretty hard to do that.
Yeah. So if I would ask why would someone care about MLOps, then basically this is the answer, right?
Yeah, that's the reason. Yeah, it's mainly about reproducibility of the model. You want to make sure that everything that runs in production is reproducible. So I can go back to the original data and the original code and the original settings that I used to reproduce that model in case something goes wrong or somebody asks, why did you make that decision actually? That's a lot of people are asking that these days.
Yeah.
Some companies are using AI for pretty impactful decisions, and in that case you have to be able to explain it, so reproducibility is a thing.
Yeah.
The other thing is, and we know this from software engineering, it runs on my machine is not good enough. It's not going to happen. So you have to make sure that so you have to make sure that you have some sort of method that eliminates human error. So that's the other reason why we think MLOps is an important part of doing machine learning in production.
Yeah, because it's just a production process of producing data, so you need to have that process right.
Yeah.
Okay. Given that a lot of companies might not be doing MLOps or might not be doing it in the right way, how could they start doing it in the right way?
Well, there are actually many options or maybe like frameworks that we can follow to do so. So I would say it's not a good idea to try to do everything from the start because it can be very overwhelming, or at least whenever we try to build something, even for a demo or for a course or something, it's just like you need to consider too many things. So, well, there's, for instance, these, I think it's called like the MLOps maturity model by Microsoft, and they have, I believe, 4 steps.
Yeah.
So they start with, of course, no MLOps at all. Then you can go to DevOps, but no MLOps. So since I mentioned that we have code and data and, well, a model, or the configuration that defines the model, we could start just with DevOps, which means just applying it on the code. Of course, in a machine learning project, the code that we normally deploy for production is just maybe the inference endpoint, so an API or something similar. So it's very little, like a very small part of
it's a box.
Yeah.
Yeah.
But it's a good starting point, I would say. Just first have all the DevOps practices on the parts of the project that are just like regular software, a regular software project. Then the next one would be to have automated training, because in the end that's the part that can be a kind of like a pain point in a project, that if we need to retrain, then we change something, we get some model, but we didn't track what we changed, so how can we know how it compares, how it relates to previous models? So that would be the next one. Then when we have that, we can go to automated deployment. So not only the training and releasing the model manually, but also having just automated.
The automated CI/CD pipelines, basically, yes? Yeah,
of the model and of the endpoint. And then just the last one would be everything, so that plus monitoring.
And I think if you look at a single project, so this is sort of, the maturity model talks about long-term improvements within your company if you want to start with machine learning. But in a single project, you can start with experimenting and then focus on engineering and then on monitoring. So what I mean by that is that experimenting, I think a lot of people have heard about Python notebooks. And that's an excellent way to try things out quickly on your machine. You don't have to worry about versioning. You don't have to worry about automated pipelines or tests for that matter. You can just try it out and see what happens. But once you are at a point where you decide, okay, this is going to work in production, probably, then comes the engineering part. And then you can switch focus. You can say, I'm taking this code that I wrote in the notebook, I turn it into a data pipeline and a training pipeline, and I'm going to write tests for that, so I can be sure that it works every time, and then I can start focusing on a deployment pipeline and bringing that to production. And then once you've deployed it to production, then you can start to worry about the monitoring part of MLOps, and you can start to think of, okay, so I'm recommending products to a customer for an e-commerce platform. How do I gather feedback from that person if that's actually the thing that they want? Are we giving the right recommendations?
Positive feedback, you mean?
Yeah. Feedback, is it right, is it incorrect? But also, so we mentioned earlier that there's a changing world out there, so you have to deal with data drift.
Yeah.
There's data in production that doesn't look like the development environment. You can monitor that. You don't have to do that right away, but you can shift the focus towards that once you are in production.
Yeah, the last step Lucía mentioned.
Yeah, and it can be simple. So what Lucía mentioned is actually start with a few of those ideas, a few ideas in experimenting, a few ideas in engineering, and a few ideas in monitoring, and then increase that over time.
Yeah. And I think the rule is as soon as you start to make real business decisions based on the outcome of machine learning models, then it will obviously be very important that you have this process in place.
Yeah, absolutely. I think that's for everyone. There is a slight variation in the sense that if you're working for a medical application, then the requirements are more strict, of course.
Yeah.
If you're working for an e-commerce platform, it might be less strict. But that's up to people to decide for themselves what are the requirements for me.
Giving the consumer wrong advice on a movie he has to watch has a different impact than a doctor.
And Netflix, you can always stop and go back and choose another movie. But if a doctor misdiagnoses you using AI, that's a whole different thing.
Yeah. An important part of DevOps, machine learning ops, MLOps, DataOps is testing. You mentioned it already. How do you test the correct working of an AI model? Because it's not rule-based. And that's the difference with rule-based programming.
Yeah. There's not an easy answer to that, but the way that we think about this is that so in machine learning, you write a program that generates a program, if you will. It's sort of that thing. So what can you unit test? Well, you can unit test the code that's training the model. For example, if we look at a neural network, it accepts input of a certain shape. So neural networks use matrices. And a matrix that goes into the model could be 3 by 3 by 3. Mm-hmm. So you can write a unit test and verify that actually works. And it produces some output. You don't know if that's the correct output. That doesn't matter at that point. It has to go through the neural network and it has to produce output. That's one unit test.
It doesn't break, basically. Mm-hmm.
So that sort of test you can run. Then the second part, of course, it generates another program, a model. You need different types of tests for that one as well. And in that case, it would come down to performance metrics like accuracy, precision, error margins, but also, and I think you've done some research in that area for explainers. You can let the computer explain the model and then look back. So we predicted that this is someone who's going to try and rob the bank. Is that for the right reason? And you can take a look back. You can break open the black box and look inside.
Yeah, but that's more on the explainable AI part than...
Yeah. But which is also part of monitoring. So for instance, the example that Willem gave on a medical application, like maybe for something like that, monitoring is more essential, and you should monitor for biases or for, in general, you need to have explanations. So it also really depends on the application and what's more critical to be tested or not. But in the end, it's quite challenging to test, or to unit test, especially a machine learning application. But like Willem mentioned, it's either like you need to test the things that are certain, so things like the formats of the input data, the formats of the output data, but you cannot really test so much on the functional side. So you cannot maybe write a unit test that says, for this input, I want this output, because of course that's what you want, but you don't know if the model is going to actually predict that. So that's why for that part, for more of like the functional part of the project, you should use the performance metrics rather than like actual unit tests.
Yeah, and the feedback loop that you described, which is also important in a production environment.
I think actually that the feedback loop is the most important one to us.
Yeah.
And this is why, so many people will know from software engineering that you have a development environment and a test environment, acceptance and production. Actually in machine learning we prefer to have a development environment, an acceptance environment, and then production. We skip the whole test thing because that doesn't give us a lot of value. Yeah. There is some value in it, mainly for integration testing because machine learning doesn't exist on its own. Mm-hmm. But in production, this is where we gather the feedback. And often what we use is A/B tests. So we have two versions of the model. Yeah. One is actually giving you back the prediction. The other one makes a prediction, but we only store that. And then afterwards, we can go back to our monitoring system and say, okay, we've tried version 1 is active at the moment, version 2, oh, that's better. Okay, we can flip them around. And we can replace version 1 with version 3 and improve again. I think that's actually the most important trick to have up your sleeve if you want to be a successful machine learning.
Yeah, also because using other environments in a machine learning project can be quite challenging and also maybe not even possible because in the end everything is based on the data, right? But maybe depending on the company you're working for, you might not be able to use production data on the development environment or the acceptance environment. But then you cannot really, you will never have the same version that you need to test. Compared to a regular software where you're testing the rules, but here you don't define the rules, so you need to test it against data. So that's why A/B testing is a good way and a more secure way maybe to test such an application.
And the reason, so it also goes back to the reason why would you use AI in the first place. If you could solve it with rules, we recommend always using rules. AI is actually something. You're trying to help a human to become better at making a certain decision, making sense of a lot of data at once. That's where AI shines. So that's also the reason why we prefer testing on production actually. It's about the interaction with the human behind the computer. That's adding the value to this whole idea of using AI. So yeah, for me, acceptance is all about does it perform right, but not about functionally correct because we don't know.
Yeah.
And of course it will depend on the application of the AI, because if you're really augmenting people, like you just described, then it is less important that the model is not 100% functionally correct.
Exactly.
Than when you use it in full automated scenarios.
Yeah.
For example, the ones that they use on the stock trading, or then it could be.
Yeah, then it becomes more important. That's also so. In some scenarios, we use pretty limited set of tests, so we only do A/B testing. But in other cases, we have more techniques in the area of explainable AI, things like counterfactual. So first, we let the computer predict samples that we expect to be right, and then we let the model predict samples that should be wrong. And if it doesn't get them wrong, then we know, uh-oh, there's something up. And we have to pull things apart and look at what's going on inside the model. Do we have the right data, for example?
Yeah.
But that's a lot more complicated. If you can do it with an A/B test, please do it with an A/B test.
Yeah, but that's always how you should implement tests. What risk are you taking? What are you willing to take?
Yeah.
And how do you want to mitigate it? How complex will that be? And
yeah,
so
absolutely.
And it's a big part of also monitoring machine learning that, I think it's applicable to anything, but in machine learning it's really always a good idea to check what the concerns of the stakeholder are, and then test for that and monitor for that. So let's say, for instance, in a medical application that it's very critical, right? Maybe the worst concern could be that the application never predicts that someone has a certain illness, let's say, rather than if it always predicts it, even if it's wrong. But at least that way a human will check it and stuff. But if it never predicts, if it never gives a positive result, then that's really bad. Yeah. So that's something that you should always monitor for, like before anything else, or maybe even before fairness or before regular performance metrics. Just have some kind of test or monitor metric that checks the recall in this case. So if like all the true positives are actually retrieved.
Yeah.
So it really varies on the application.
Thanks.
You're welcome.
You've given me a lot more background on MLOps and what it is, why we should care, and how we can do it. terugschakelen naar Nederlands. Ik hoop dat jullie ook een goed idee hebben gekregen over wat MLOps is en hoe het zich verhoudt tot DevOps en DataOps. Als je dit een leuke video vond en als die je geholpen heeft, klik even dat duimpje omhoog. Abonneer je op het kanaal zodat je altijd weet wanneer er weer een nieuwe aflevering is. En voor deze aflevering bedank ik je voor het kijken en graag tot de volgende keer.